Hello, my name is Gerald Aguila from the University of Santo Tomas, and I'm going to show you a diagram of the view of operating system services. So in this part is the user interfaces. The user interface is where users can issue commands to the system. It can be in the form of graphical user interface, batch processing, or command line. For GUI, it's just a front end for activating a traditional command line interpreter running in the background. The batch processing is where the execution of a series of jobs in a program on a computer without manual intervention. The execution of a series of programs each on a set or batch of inputs, rather than a single input. For the command line is where interacting with a computer program where the user issues commands to the program in the form of successive lines of text. The next part is the system calls. The system calls provides a mean for user or application programs to call upon the services of the operating system. It is generally written in C or C++, although some are written in assembly for optimal performance. In this part, this, this includes the services of an operating system, including program execution, input-output operations, file systems, communication, resource allocation, accounting, error detection and protection and security. For program execution, the system must be able to load a program into memory and run the program. The program must be able to end its execution. The next is the input and output operations. A running program may require input-output, which may involve a file or an input-output device. For efficiency and protection, users usually cannot control input-output devices directly. Therefore, the operating system must provide means to do input and output. For the file system, the program needs to read and write files and directories. They also need to create and delete them by name, search for a given file, and list file information. Finally, some programs include permission management to allow or deny access to files or directories based on file ownership. The next part is communication. Communication is the process running on the same processor or between processes running on separate processors or separate machines. They may be implemented as either shared memory or message passing. The next is the resource allocation. This is where multiple users or multiple jobs running at the same time, resources must be allocated to each of them. For instance, in determining how best to use the CPU, the operating system have CPU scheduling routines that take into account the speed of the CPU, the jobs that must be executed, the number of registers available, and other factors. There may be also routines to allocate printers, modems, USB storage devices, and other peripheral devices. Next is accounting. The accounting, we want to keep track of which users use how much and what kinds of computer resources. This record keeping may be used for accounting or simply for accumulating usage statistics. Then, error detection. Both hardware and software errors must be detected and handled appropriately, with minimum of harmful repercussions. Some systems may include complex error avoidance or recovery systems, including backups, RAID drives, and other redundant systems. Debugging and diagnostic tools aid users and administrators in tracing down the cause of problems. The next is protection and security. The owner of information stored in a multi-user or network computer system may want to control use of that information. When several separate processes execute concurrently, it should not be possible for one process to interface with the others or with the operating system itself. Protection involves ensuring that all access to system resource is controlled. So we move on to the next diagram. This is the layered approach of the operating system. The layered approach with proper hardware support, operating systems can be broken into pieces that are smaller and more appropriate than those allowed by original MS-DOS or Unix systems. The operating system can then retain much greater control over the computer and over the applications that make the use of that computer. Layered approach in which the operating system is broken up into a number of layers. The bottom layer, or layer 0, is the hardware, and the highest, layer N, is the user interface. A typical operating system consists of data structures and a set of routines that can be invoked by higher level layers. The main advantage of layered approach is simplicity of construction and debugging. The layers are selected so that each uses functions or operations and services of only lower level layers. This approach simplifies debugging and system verification. Once the first layer is debugged, its correct functioning can be assumed while the second layer is debugged, and so on. If an error is found during debugging of a particular layer, the error must be on that layer, because the layers below it are already debugged. Thus, the design and implementation of the system is simplified. Thank you for listening.